In this video, we're going to be taking a look at the product and quotient rules, and then also higher order derivatives, and we'll talk about what that means. So here's just a product and quotient rule right there, but we're going to be going over those. So first of all, the product rule, the definition of the product rule is as follows. If you're finding the derivative of two functions being multiplied together, hence the product rule, it's essentially the first function times the derivative of the second function plus the second function times the derivative of the first function. Now remember, since multiplication is commutative, you can do these in whatever order you want to. Okay, so that is the basic definition for the product rule. Now let's try some examples. Here, this is your f of x, and this could be your g of x. Go ahead and try to apply the product rule to find the derivative of this function here. So when we find the derivative here, we are looking at the derivative of the first times the second. So we have the derivative of the first. It's the derivative. I did the first times the derivative of the second, plus the second times the derivative of the first. And then here, you're going to have to end up multiplying these in. So you can think of having to distribute to get these terms down here. You can put the 18x to the third and the 6x to the third together to get 24x to the third. And your final answer is the derivative of the function is 24x to the third plus 15x squared minus 12. Okay, let's go ahead and try this one. You have the two functions being multiplied together, e to the x and sine x. Go ahead and apply the product rule to find the derivative here. So let's take a look at this one. We have e to the x times sine of x, so it's going to be then the derivative of e to the x, which is e to the x on both of those, but on one of them we have to multiply by the derivative of sine, which is cosine here. So on the first part, it's e to the x times the derivative of sine plus the derivative of e to the x, which is e to the x times sine of x. You notice they both have an e to the x, which is why I was able to factor it out there. So you're left with e to the x times a quantity of cosine x plus sine x. Okay, now that we know what happens when we multiply them, what happens if we were to divide them? So let's take a look at the quotient rule. So the quotient rule is what do we do when we have functions that are being divided, right? So it's going to be similar to the product rule, and that it's going to be the lower function. So the order is important here because subtraction and division, not commutative like addition and multiplication. So it's going to be the lower function, so g of x times the derivative of your upper function minus your upper function times the derivative of your lower function, all over your lower function squared. So g of x and then this squared. That is the quotient rule. So one way that you can remember this a little bit better, I'll never forget my college professor, Dr. Donges, singing this. I am not going to sing it for you because I'm not as amazing as Dr. Donges was, but it's if you have your high function, so here it's high over low, and you're finding the derivative of those two functions. High is a function, low is a function, just like f of x and g of x. It's going to be low d high, so low times the derivative of the high, minus high times the derivative of the low, so that's where the d low comes from, all over low. So low d high minus high d low, all over low. And she would sing like she was one of the 7 dwarves That's how the song goes. So if you want to do that, go ahead. I'm not going to do that for you. So that is the quotient rule. Moving on, let's go ahead and try some examples. Go ahead and try 1 and 2. If you need help, go ahead and unpause the video, but otherwise pause the video, try these on your own, and then come back and see how you did. So if we take a look at this first one here, you have high over low, so high and low. So it might be easier just to find the derivative of the high, which is 1, the derivative of the low, which is 1/2 s to the negative 1/2. Remember using the power rule, the square root of s. Let me do this down here real quick. The square root of s is s to the 1/2. Using the power rule, we would take this 1/2, bring it down, and end up subtracting a half. So then that would become 1/2 s to the negative 1/2. So that's where that came from. Erase that. Now we go ahead and do the low d high minus high d low all over low low. And this is what we have. Low d high minus high d low over low low. We could probably stop there. So if you're ever asked just to find an equation for the derivative, stop there. Because at this point, this is where if you were to find the derivative, you would have the value of s, where they want you to find the derivative. Otherwise, you can stop there, but this can be simplified just a little bit, not too much. So this could be square root of s minus 1 minus, and this could be s over 2 square root of s all over square root of s minus 1 squared. And we're not going to bother multiplying that out. So I guess that didn't make it much simpler at all, but it just kind of simplified it as far as we could go. So this is the derivative using the quotient rule. Let's take a look now at the second one. If you haven't had a chance to try the second one, pause the video and try it before you come back and look at the answer. So if we take a look here, you have your high and your low functions. Derivative of the high is negative sine of x. The derivative of cosine is negative sine. Derivative of low is just e to the x. So you do low d high, I have that negative out front there, minus high d low, and the d low is the e to the x here, and your high is just cosine over low low, so e to the x squared is the same as e to the 2x. And then on this one, you could stop here. You could go also one further and notice that, hey, negative e to the x is a common function or a common factor. And so I can take that out. So you would have then sine x plus cosine x. Not sine here. So cosine x. All over then e to the 2x. And you notice you can take an e to the x out. So if we go even one further, negative sine x plus cosine x all over e to the x. And that would be as far as you could go. This is the equation of the derivative right here. And this is where, if you know what the x value is, that's where you would go ahead and plug it in. Let's do another example. On this one, you're going to have to rewrite this thing before you differentiate it. So go ahead and try rewriting it. If you needed to rewrite it, I guess you don't have to, but it would make things a lot easier. And I'm actually going to do it both ways. Just way number one, just using the quotient rule, and way number two, rewriting it to see if we can get the same thing. So see if you can't try to do this two different ways. Okay, so let's take a look at this doing both ways. Number one, we use the quotient rule, and then we rewrote it. So using the quotient rule, low d high minus high d low over low low. And then that simplifies. I left it as the factors because you notice here the 11s will cancel, and you're left with just 10 over 11 times x, or 10 11s x. Then if we rewrite it, you can bring this 11 in the denominator out, and then you're like, hey, 5x squared, I can also, so it's times this whole thing. So it can't really do this. So let's ignore this step right here. Sorry about that. But when you find the derivative, it's 1 over 11 times the 5x squared minus 8. And the derivative of 5x squared minus 8 is just 10x minus 0. So 10x times the 1 over 11, which is where I get 10 over 11x. And we get the same thing. So think smarter, not harder when you are working on these. Think 10 seconds of looking at the problem and thinking about the problem might save you 10 minutes actually working on the problem. So think smarter, not harder, especially as we learn new ways to do some of these problems. Okay, so now let's take a look at the derivatives of trigonometric functions here. The derivative of tangent is secant squared. Derivative of secant is secant tangent. Derivative of cotangent is negative cosecant squared. Derivative of cosecant is negative cosecant cotangent. Now, all of these, you can find all of these by thinking of sine and cosine, quotient, product rule. Because, for example, tangent is just sine divided by cosine. So this is just sine of x over cosine of x. And so if you're finding the derivative of that, it'd be low d high minus high d low all over low low. So low d high, right? The derivative, so cosine x times the derivative of sine is cosine of x. So it's going to be then the low d high, so cosine x minus high, which is sine of x, times the derivative of the low, which is negative sine of x, all over low low, all over cosine squared. And then if we simplify this, I'm just going to move right over into here. Cosine times cosine is cosine squared, so cosine squared plus sine squared all over cosine squared. Now, this should look familiar. In the numerator here, cosine squared plus sine squared, that's equal to 1. So then you would have 1 over cosine squared, and 1 over cosine is secant. So 1 over cosine squared is secant squared. And that brings us right back. We found the derivative using the quotient rule, and we got secant squared. So if you're ever on a test or quiz and you forget the derivative of any of these, you could say you forget the derivative of secant, the derivative of tangent, cotangent, cosecant, or secant. Just change them into terms of sine and cosine, like secant is 1 over cosine, cosecant is 1 over sine. Change them, use the quotient or product rules, and find the derivative that way. Now, go ahead and try this one. Finding the derivative of this particular trig function, you can use this identity up here. The derivative of cotangent is negative cosecant squared, and then simplify as far as you can go. Pause the video, try this one, and then also try the next one down here, the derivative at a point. Try that one as well, and then come back to the video. Okay, so let's take a look at this first one here. You have the derivative is pretty straightforward. The derivative of your e function is just e, and the derivative of cotangent is cosecant squared, actually negative cosecant squared, and so that should be a plus cosecant squared x. That's as far as you can go. You can't simplify those any further. However, on this next one, you can simplify all the way down to the answer of 0. So let's take a look at how we get that. So first of all, let's do the product rule. So we have the derivative of tangent, which is secant squared times cotangent, plus tangent times the derivative of cotangent, which is negative cosecant squared. If you had a value of x, you could even plug it in right there. However, we don't have a value, we do have a value of x, but we're going to go ahead and simplify this even further because secant squared is 1 over cosine squared, cotangent is cosine over sine, and you notice here the cosine and cosine will cancel, so you just have a cosine of x in the denominator, which is where this came from, cosine x times sine of x, because you have then cosine times sine in the denominator and just a 1 in the numerator. On the second term, you would change tangent into sine over cosine, cosecant squared into 1 over sine squared. Don't forget about that negative, because the derivative of cotangent is negative cosecant squared. And then also you have the same thing going on here, where the sine and sines will cancel, and you have then the sine of x times the cosine of x, so you would end up multiplying those together to get cosine of x times sine of x, and don't forget about that negative 1 on top. Now here's where it gets interesting. You notice these are exactly the same, except this is a negative, which is how we got 0. So at every single point, no matter what the coordinate is, the slope is 0. Now let's take a look at these higher order derivatives. With the higher order derivatives and the application problems, this S of t that we often use, that is indicative of the position function. All right, so S of t is the position function. So when we find the derivative of S of t, that's the same thing as the velocity function. And then if you find the second derivative of the position, which is the first derivative of the velocity, that gives you your acceleration. So we have the acceleration function is the second derivative of the position function, and the velocity is the first derivative of the position function. So those are your higher order applications. If you want to find any of the acceleration, velocity, or position, they're all there. Let's go ahead and try some examples. Go ahead and try this one and see how you do, and come back and check your answer. Okay, so let's take a look at this one, see how we did on here. So the first derivative, it's low d high minus high d low over low low. Then when we simplify that, we are having to multiply this n on that one, and you end up with 2x squared plus 2x minus then all of this inside the parentheses, which is x squared plus 2x minus 1. But you have to just distribute that negative in there, and when we do this, the 2x squared and the negative 2x will simplify down to just 1x squared, and then the 2x and the negative 2x will cancel each other out, giving you just then plus 1. So x squared plus 1 over x squared. That's the first derivative. And if you didn't find the second derivative, just for funsies, go ahead and try to find the second derivative. Once you're here, find the second derivative. Okay, let's go ahead and try to find the second derivative. And we're finding low d high minus high d low. So here's your low, here's your high. So low times the derivative of high minus high times the derivative of low over low low. So that's x squared squared, which is where the x to the fourth comes from. And then when you multiply things out, you would get 2x to the third minus, because now you have to take this 2x and distribute in, which is where the 2x to the third plus the 2x comes from. And then when you distribute this negative into the parentheses there, you end up with 2x to the third minus 2x to the third, which is they cancel each other out, then minus 2x. All over x to the fourth, take an x out of each of those, so you get negative 2 all over x to the third, and that is our second derivative. And that is it for the product and quotient rules and higher order derivatives for 3.3.